Welcome to Lesson 5. In Lesson 5, we will learn the definition of the mean aerodynamic chord and how to convert the center of gravity given as a percent of the mean aerodynamic chord to one expressed in inches from datum and vice versa. We will also learn to find a new center of gravity expressed as a percent of Mach. More in-depth information about the mean aerodynamic chord can be found in FAA Handbook 8083-30 and the FAA's Aircraft Weight and Balance Handbook, which can be viewed in the course content area of this course. Thus far in this course, we have expressed the center of gravity in inches from datum. In larger aircraft, the center of gravity is usually expressed as a percent of the mean aerodynamic chord. The chord of a wing is the distance between the leading edge of the wing and its trailing edge. However, the chord of a wing is not constant throughout its entire length for most aircraft because their wings are tapered, and the leading edges and trailing edges of most wings are not a constant distance from the datum because of wing taper. The mean aerodynamic chord is the chord of an imaginary wing with the same aerodynamic characteristics of the actual wing, but with a constant chord and with a leading edge and trailing edge at uniform distances from the datum. In this picture, we can identify the leading edge of the wing, the trailing edge of the wing, and we can see that the wing is tapered and that it narrows as we move out from the fuselage. We can also see that it is swept and that it moves back from where the wing joins the fuselage. In the dotted lines is pictured the mean aerodynamic chord, which is an imaginary wing with the same aerodynamic properties of the real wing. The two equations on this slide will help us in solving our weight and balance problems using the mean aerodynamic chord. The first equation, the one in green, is utilized when we need to convert from a center of gravity given in inches from datum to one expressed as a percent of Mach. The second equation is used when we need to convert from a center of gravity given as a percent of Mach to one expressed in inches from datum. In either instance, we will be given both the leading edge mean aerodynamic chord and the trailing edge mean aerodynamic chord expressed in inches from datum. Let us work an example now of a problem where we have the center of gravity given in inches from datum and we need to convert it to a percent of Mach. We will utilize the equation percent of Mach equals the distance between the center of gravity and the leading edge times 100% divided by the distance between the trailing edge and the leading edge, where our center of gravity is given as 172.6 inches aft of datum. The leading edge is given as 153.2 inches from datum, and the trailing edge is given as 227.3 inches from datum. First, plug these values into our formula and we get the percent of Mach equals 172.6 inches minus 153.2 inches times 100%, and this value divided by the difference between 227.3 inches and 153.2 inches. After performing the subtractions into parentheses above and below the divisor line, we get 19.4 times 100% divided by 74.1. Then after performing the necessary multiplication and division, we get our center of gravity expressed as a percent of Mach is equal to 26.2%. Let us now work an example of a problem where we have the center of gravity given as a percent of Mach and we need to convert it to inches from datum. We will utilize the equation center of gravity equals the percent of Mach divided by 100% times the distance between the trailing edge and the leading edge, and to this value we add the distance from the leading edge to the datum. Where our center of gravity is 32.8% of Mach, our leading edge is 121.6 inches from the datum, and our trailing edge is 198.4 inches from the datum. First, plug these values into our formula, and we get 32.8% divided by 100% multiplied by the difference between 198.4 and 121.6, and then to this we add 121.6. After performing the subtraction in parentheses, we get 0.328 times 76.8 plus 121.6. After performing those last calculations, we find that our center of gravity, expressed in inches from datum, is 146.8 inches. After an aircraft has uploaded or unloaded cargo, passengers, or fuel, the new center of gravity must be determined. If the center of gravity is given as a percent of Mach, determining the new center of gravity is a three-step process. In the first step, convert our center of gravity from a percent of Mach to inches from datum. In the second step, calculate a new center of gravity, and then in the third step, convert our new center of gravity from inches from datum to a percent of Mach. In this example, let us find the new center of gravity of an aircraft expressed in percent of Mach after cargo has been removed. While still loaded, the aircraft weighed 92,480 pounds and had a center of gravity of 39.1% of Mach. 9,650 pounds of cargo were removed from a location 193.1 inches from datum. The leading edge was 126.4 inches from datum. The trailing edge was 211.5 inches from datum. We will find the new CG of this aircraft after the cargo has been removed as a percent of Mach. The first step in this process is to convert our center of gravity from a percent of Mach to inches from datum. We will do that utilizing the formula center of gravity equals percent of Mach divided by 100% multiplied by the difference between the trailing edge and the leading edge, and add to this value the distance from the leading edge to the datum. We will then insert our given values into that formula, and that will give us 39.1% divided by 100% multiplied by the difference between 211.5 inches and 126.4 inches, and then add to this value 126.4 inches. Once these calculations have been done, we find out that our center of gravity in inches from datum is 159.7 inches. The second step in this process is to calculate a new center of gravity after the cargo has been removed. To do this, we will again use our item, weight, arm, moment chart. The two items in this chart will be the weight of the aircraft before the cargo was unloaded, and then the cargo itself. The aircraft itself before the cargo was unloaded weighed 92,480 pounds, and its center of gravity we found out was 159.7 inches. The cargo, we removed 9,650 pounds. Since this weight is being removed from the aircraft, it has a negative value. Its arm was 193.1 inches. Now we have the information we need to compute the two moments, the moment for the aircraft itself and the moment for the cargo that is being removed. Recall that cargo being removed is a negative value multiplied by a positive arm is going to give us a negative moment. Once we have those values, add them together to come up with a total moment, sum our weights to come up with a total weight, divide our total moment by our total weight to get our new center of gravity, expressed in inches from datum, of 155.8 inches. The third step in this process is to convert our new center of gravity from inches from datum to a percent of Mach. To do this, we will utilize the formula percent of Mach equals the difference between the center of gravity and the leading edge divided by the difference between the trailing edge and the leading edge, then to multiply this value by 100%. Once I input the values into this formula and perform the necessary calculations, I find out that my new center of gravity after the cargo has been removed is 34.5%.